Hi everyone, good afternoon.
Good afternoon, Johnny.
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 Good afternoon. Glad to see all of you here. Really nice. I hope you all have checked your inbox and you have received one very beautiful email today, just a couple of minutes back.
Yeah, we have.
All right. So let me ask you, did you do something about it? Yes, no?
Actually, Johnny, we have just got the mail and we are just reading it. So may I ask for some time?
Yeah.
Okay.
All right. Have our post for the day, Nancy. Yes.
Hi, Johnny. Can you hear me?
Yes, Mansi, we can hear you loud and clear.
Great.
So I have made you the presenter. And,
yes. Okay.
Can we wait for a couple of minutes, maybe 2 minutes, and while rest of us join us.
Okay.
Meanwhile, would request everyone if you look at the participants list and if you see anyone missing here and is part of your team, you may please ping and request the member and your friend and colleagues to join us. We are about to start.
Johnny, I have a question. Is there any feature of recording the presentation in WebEx? Because although I do have a recorder, but do I need to use it, or do we have an option here?
Wonderful question, Mansi. Now we do not have the requirement to record these sessions because WebEx has this auto feature. It records the meeting.
Okay.
It records the session automatically.
Okay. So I do not need to start my recorder?
Yeah, you don't need to. I mean, you can record if for your personal use if you want to go back, refer it back.
Okay.
Again. All right. So I'm sure everyone, we all are aware that there's a cultural program or rather an initiative which is rolled out across the organization, emphasizing discovering the awareness that we may have towards the culture of the organization. What is culture? What are the driving elements? What drives it? What it your drives are. All right. So only 55 have joined. I would request the team managers and everyone else to look at the participants list, and if you see that anyone who is missing or is not here, you can please go back and ask, or maybe share a post in your respective work chat rooms and channels, so that everyone joins us here. And we are going to do a very wonderful and very exciting, very wonderful discovery today on the Scala Variance through our coach for the day, who is Mansi Baba. So really excited and looking forward to have this discovery, Mansi.
Thank you. So shall I start?
Yes, I believe let's not wait anymore. So thanks, Mansi, for being here. Would like to pass on the platform to you. And thanks everyone for coming over. Over to you, Mansi.
Okay. Sharing my screen, just a sec. Okay. Is my screen visible? I hope it is.
Yeah, it's visible.
Okay.
Yes.
Okay, great. So, hi everyone, welcome to today's Knowledge. It's about Scala Variances. I hope you all are aware of Scala language. So, today we are going to cover one of its key feature of variances. So, let's start. But before proceeding with the session, I would like you to follow these knowledge etiquettes. Please be punctual, respect knowledge session timings, and make sure to submit a constructive feedback as it is very important for the presenter. And please keep your window on mute and avoid leaving your window unmuted after asking a question. So this is today's agenda. First, we are going to cover what is variance. Then we are going to see what are the types of variances. And then we will see, there are many types of variances, for example, covariance, contravariance, invariance. And then we will talk about why we need that particular kind of variance or what is the significance of that particular kind of variance. Then we will demo on these two major variances, which is covariance and contravariance. And then we'll wrap up the session with some summary. Okay, so this is the first topic. What is variance? So basically, variance is the interconnection of subtyping relationship, which is either of complicated types or of their constituent types, right? So it's like in Scala, we can create many complex types, right? We can define our own types, right? So it's basically, you can define a subtyping relationship between those complicated types and their component types, okay? And variance is basically, it is related to the ability to use more generic or more specific than the type that is originally defined. Right? We have primitive types in Scala. We all the primitive types that we have in Scala. So we can also create more generic types, and we can define the relationship between those generic type and their subtypes, basically, invariants. So we will see how that works. It's just the theoretical concept here. So variance is all about subtyping. It tells us if a type constructor is a subtype of another type constructor. Okay. Basically, do not get scared of these terms, subtyping, type constructor, and parameterized types. I'm gonna cover these three terms in detail in the later slides. So just try to get the overview of variance. So it's basically about subtyping. It tells us if a type constructor is a subtype of another type constructor, and it defines inheritance relationships of parameterized types. What are parameterized types? Those are the types that have parameters within them. We'll see what they are, okay? So let's take an example to make it more clear. Think of a list. We have list in Scala, right? So think of a list. So you cannot define a list without specifying which type will be inside the list, right? Whenever you define a list, you always specify that what type of list is it going to be, right? So you do it by putting the type contained in the list inside these square brackets, like list, square bracket, string, square bracket, close, something like that, okay? So when you define so this is basically a complex type. So when you define a complex type, you can specify how it will vary its subtype relationship according to the relation between the component type and its subtypes. So what I'm trying to say here is that if we define a list, let's say we define a list of type float. Okay, list of type double. Okay, and let's say we define a list of type any. So basically, you know that both are lists, and also you know that any is super type of double, or list of, let's say, list of int. So any is super type of int, right? So now, since any is super type of int, so how is it going to affect the relationship between list of any and list of int? So that we will cover, okay? That how we specify the relationship between the component type and its subtypes, okay? So So moving on to so basically this was one of the term that I mentioned in the last slide, subtyping. So let's see what exactly subtyping. So in every programming language, it supports the concept of types, right? Types give information to a program about how to handle values at runtime. So now subtyping, it adds more constraints to the values of a type, right? For example, let's take this example. Let's say I created a trait called polygon, okay? Now, if I create a case object called parallelogram and it extends polygon, okay? So this is an example of subtyping. Like that means parallelogram is a subtype of polygon, okay? Because it extends polygon. Now, if I create a case object called rectangle and it extends parallelogram, so now rectangle is a subtype of parallelogram. And if I create a case object square and it extends rectangle, so now square is a subtype of rectangle. So here I have created a hierarchy of types, right? So this is basically subtyping. Next term that we heard was type constructor and parameterized types. So basically, it's like, so basically variance, it explains inheritance correlation of types that have parameters or arguments within them, okay? So these types, they belong to the generic classes, right? I hope you have heard of generic classes. So which takes a type like a parameter. Okay. So in the presence of variance, one can create relations between complicated types, and in its absence, we won't be able to reiterate the abstraction class. So basically, if we look at this example, so what are we doing here? You see an example of list of T, right? So this T is basically a type parameter, which is basically a generic type, right? And this whole list of T is a generic class, or you can say type constructor, right? So type constructors, they are a mechanism that creates new types starting from the old ones. So they provide type variables that we can bind to concrete types. What are our concrete types? Like string and int. So those are our concrete types. So basically we can create a generic type and then we can bind it with a concrete type. So for example, if I create a list of T, I can bind it with a list of string, list of int, right? T can be any kind of type, right? So here T is the type parameter and list of T as a whole is a generic class, or you can say a type constructor. Okay. Moving on. So let's come to the next topic, that is what are the types of variance. So I hope what are variance is clear till now. So let's see what are the types. So basically there are three types of variance. First is covariance, second is contravariance, and third is invariance. Okay, so covariance is basically, it preserves the relationship of subtyping. You know, for example, any is super type of int, right? So if I create list of any, then and list of string, so list of any should be the super type of list of string. So it basically preserves the relationship of subtyping, right? Contravariance, on the other hand, it reverses the relationship. And invariance, we just ignore those relationships. So we will cover them, each of them in detail. So let's start with covariance. So basically, covariance is okay, before looking at what is here on the slide, just let's take a small example. For example, if we think of a question like, if dogs are animals, right? Could list of dogs be considered as list of animals? This is the question. Like, if dogs are animals, of course, then can we consider list of dogs as list of animals, right? So this is the variance question. That is whether the subtype relationship can be transferred to generic types, right? we know that dog is a subtype of animal. So is that relationship gonna be transferred to like list of dogs to list of animals, right? So if the answer to this variance question is yes, then we consider the generic type as covariant. That means if dog is a subtype of animal, then list of dogs should be considered as a subtype of list of animals. Okay. So if you look at the easy example here, so if S is subtype of T, then we can say list of S is subtype of list of C. So this is an example of covariance. Okay. And how can we represent it in Scala? So basically, this is how we represent it. For example, we have a type constructor list of T. If we put a plus sign over here, this basically denotes covariance. Okay. So this is how you can specify a list, a covariant type. Okay. So covariance is basically a concept that is very straightforward to understand. We say that a type constructor list of T is covariant if S is a subtype of type T, and list of S is a subtype of list of T, right? So in Scala, we declare a covariant type constructor using the notation like list of plus T, adding a plus sign on the left of the type variable. Okay, this T is a type variable. So in this case, covariance is basically type safe. You can say covariance is type safe because it reflects the standard behavior of subtyping, right? So basically assigning an object to a variable of one of its supertype is always safe here. So now the question arises, why do we need covariance? So I think it's pretty much clear till now that why do we need it, but still, okay. So when your generic type, if it contains or produces some elements of type T, it should be covariant. Like if my generic type list of T, it basically contains some elements of type T, right? So it should be considered as covariant. And some real life example could be this, like a cage that holds animals, a garage that holds cars, a factory that creates objects, a list, and basically which holds the element, a list or any other collection that basically holds some elements, right? So like, and also covariance, it basically makes Scala collections more type safe, right? And it gives more flexible development. So that's why we need covariance. It's pretty much clear. It basically follows the standard behavior of subtyping. Now coming to the next topic, which is a bit difficult, so be more attentive here. Okay, so next type of variance that we have is contravariance. Okay. So basically, we say that a type constructor, let's say we say that a type constructor here, list of T, is contravariant if S is a subtype of T and list of T is basically subtype of list of S. So you can see the relationship is reversed here, that S is a subtype of T, but list of T is subtype of list of S, right? So the relationship is reversed here. So this type of relationship is basically contravariance, and you can denote it like this, list of minus T, where minus sign symbolize the contravariance, and so this is basically a example of contravariant list, right? So basically when you write this minus in the generic type, it's basically a marker which tells the compiler that the generic type will have the subtype relationship exactly opposite to the type it wraps, right? So now at first sight, I think contravariance, it may seem counterintuitive. That means why do we need to have this type of relationship for type constructors? I mean, if S is subtype of T, then why do we need to build a relationship between list of T and list of S like this? I mean, list of T should be subtype of list of S. It makes no sense, right? So we will see why it makes sense. We will see that in the later slide. So when we use a type variable, basically as an input parameter to a function or a method. At that time, contravariance comes to the rescue, allowing us to define type-safe code. We'll see how it helps. So, okay. So the very good question here is like, why do we need contravariance? Because it seems that it makes no sense. So, okay. So let's take again that same example of dog and animal. So in case of contravariance, if we have a dog, this is the case of contravariance, okay? So if we have a dog, which is a subtype of animal, okay? So we would have a list of animals being a subtype of list of dogs, right? The relationship is reversed here. Dog is subtype of animal, but the list of animal is going to be subtype of list of dog, right? So, which is basically exact opposite of covariance, right? So, does this make any sense? I mean, why would we write that for a list? Why would a list of animals be a subtype of a list of dogs? It makes no sense, right? So many of us, we dismiss the variance concept, contravariance in particular, as purely academic. We just study contravariance just like, okay, this is something that we need to study, and it's not basically used in the real world, or it does not have any practical approach because it does not make any sense. But that is not true. Okay, so if we think about other scenarios of real life where we can actually find some meaning in contravariance. So let's again go back to the dog-animal relationship. So let's try to imagine something like a vet. Okay, so basically a vet is a person who can heal an animal, right? So if you want a vet for your dog, okay, you will go to a vet which can heal any animal, or are you going to go to a vet which can heal only dogs as particular? No, right? That does not make any sense. Whenever we want to heal whenever we want a vet for our dog, we always go to a vet who can heal like all the animals, any animal, right? So in this case, we want to declare a vet of dog, but instead we have a vet of animal, right? So just try to summarize it. Like, for example, dog is a subtype of animal. Okay. Now, in case of contravariance, in this case, the list of animal is gonna be subtype of list of dog. Or you can say a vet of animal is gonna be subtype of vet of dog. Right? So in this case, if you want a vet of dog, you actually can have a vet of animal. You can actually declare a vet of animal here, right? So this is how contravariance comes to the rescue. I mean, so basically it's okay. So basically, when you have generic type, it acts on or consumes elements of type T, it should be contravariant. I hope it's clear. It's a bit tough topic, but I hope it's clear. So some real life example of contravariant is, again, the vet, which heals animals, a mechanic, which fixes cars. So when you want a mechanic to fix a particular car, you are not going to go to a mechanic who fix only that particular car, right? You're gonna go to a mechanic who can fix any car. Right? Similarly, a garbage pit, a function. So, okay, I hope it's clear. Moving on to the third type of Scala variance, that is invariance. So basically, invariance is it's a third type of relationship between a type constructor and its type variables. Okay, so we say that so basically, if S is subtype of T, then list of S and list of T, they don't have any inheritance relationship or subtyping. That means both are unrelated. So we use this type of relationship. I mean, there is no relationship basically. So when you do not want any kind of relationship between the wrapper types, so you just use invariance. Okay, so this kind of relationship between two parameterized types is known as invariance, or you can say non-variance. Okay, so moving on, we'll see. Okay, so let's come to the main part. So basically here we are gonna demonstrate. I'm gonna demonstrate how covariance is implemented, how contravariance is implemented, how invariance is implemented, all in Scala. Okay. So before moving on to the code, let's take an example. Let's build an example in our mind. So let's take an example of restaurants. Okay. So we want a generic and a specialized restaurant. Okay. Every restaurant we are gonna open, we need a menu of different recipes and a possibly starred chef, right? So just think of a generic restaurant, a specialized restaurant, and all the restaurants that we're going to create, they should have a menu. In that menu, we should have recipes, and for that particular recipe, we should have a star chef, which is good at making that particular recipe. Okay. So this is the example that we're going to use in our code. So basically the recipes, they can be composed of different kind of food, for example, vegetables or meat, right? And the chef that we're going to hire, he has to be able to cook that kind of food. Okay, so this is our model, right? So now let's see how this can be implemented using Scala variances. Okay, moving on to the code. Okay, so here let's take first entity, that is food. Okay, so we have created a trait of food here, which has a method called name. Okay, so now this food basically it can be of type meat, vegetable, or so basically we can create meat and vegetable, which are basically the subclasses of food, right? And we can create white meat, which is basically a subclass of meat. Okay, so here you can see the subtyping scenario, that how subtyping works here. Okay.
Excuse me, Mansi. We are not able
Yes.
to see the code. At least I'm not able to see the code.
Oh, okay. Okay. That's an issue. 1 second. Just a second. Why are you able to see that one? I don't understand. 1 second. Are you able to see my screen?
Yes.
Okay. Now, are you able to see the code? No?
Not yet.
Okay. I think there's some issue with the WebEx. Okay, I'm gonna share the screen again. Just a sec. I think it's gonna take only one screen at one time, maybe one. I don't know. Now, can you see my screen? The IntelliJ.
Yes.
Okay, so I think I need to switch between the IntelliJ and the okay, never mind. It's okay. Okay. Yes. So basically, let's start over with the code. So basically, let's take our first entity, which is food here, and it's a trait. Okay, and it has a method called name. Okay. Now we can create basically meat and vegetable classes, which are gonna be subtype of food as we are extending food here. Okay, and then we can create a class white meat, which is basically a subtype of meat as it extends meat. Okay, so you can see the subtyping behavior here, right? This is how subtyping works. So okay, now just a sec. Okay. So basically, we can create some food instances of various type, like we can create some instances of meat, vegetable, white meat, right? So they will be the ingredients of the recipe that we are going to serve in our restaurants, okay? So let's say food, let's go to this object, food implementation. So what we're doing here is that you can see, basically, we can create an instance of meat, we can create an instance of white meat, we can create an instance of vegetable, right? So you know the relationship, right? I mean, meat is a subtype of food, as I already told you here. and white meat is a subtype of meat, and meat is a subtype of food, vegetable is a subtype of food. So this is a relationship, and we can simply create instances of these particular classes. Okay, so okay, so basically here what you can do is like it can be of type food actually. Okay, so your beef is basically, it can be of type food, but you can, you can create an instance of meat which is basically of type food only. So you can define here that the type of beef is basically food, right? Similarly here, this chicken can be of type, let's say, like this. Okay, so this is the implementation of all these classes that we have here. Now it's a bit okay. I need to stop share, go back to the slides. Okay, now got 1 second.
Just move your presentation to one screen, no?
Okay.
If you're using two screen, move it to only one screen, right? And share that. Simple.
So, okay. But in that case, then I again need to switch to the IntelliJ, right? Okay. Okay, just a sec. Okay, 1 second. Okay, you know what? Let's just continue with the code only, and at the end, I will explain the slides again. So I am just gonna continue with the code only because I think that is better. So, okay. So I hope this is clear, like the food entity and the meat, vegetable, white meat entities that we have created here. So basically they specify the subtyping relationship, right? And this is the implementation of that. Now, let's talk about the covariance. How can we implement covariance here? So as you can see here, I have created a trait called recipe, and it is of type covariant. It is covariant, right? Because you can see the notation here, right? And it has these methods, name, and ingredients. Now, if I create case classes called generic recipe, meat recipe, white meat recipe, they basically extend the recipe of type food. Okay, food, you know, the entity that we created. So basically, food is the generic type. I mean, it's basically the super type. So you can say that a generic recipe, it basically extends the type. It basically extends recipe of food. Meat recipe, it extends recipe of meat. White meat recipe, it extends the recipe of white meat. Okay, all of these entities we already talked about, right? Now, let's see its implementation. So, okay. So here, if I create an instance of generic recipe, right? So generic recipe, basically this is generic recipe, and it extends the recipe of food. So you can see here that I can simply I can simply define the type of mixed recipe as recipe of food, but I can declare it with generic recipe, right? So this is covariance. That means if my 1 second. So basically that means recipe of food and generic recipe of meat. Okay, so 1 second. Yeah, so basically if my meat is subtype of food, then the recipe of meat, it should be subtype of recipe of food, right? This is the relationship that we established in covariance, right? So it is followed here. Okay, so you can simply create a meat recipe, and it can be like recipe of meat. White meat recipe it can be recipe of white meat, because they extends that, right? Now let's talk about contravariance. So we need chefs in the restaurant, and they should be specialized in a particular recipe, in a particular recipe, right? So let's say we created a trait called chef here, and this is covariant, as you can see the minus notation, and it has these methods, it has a specialization, and it cooks something, and what it cooks a recipe of particular kind. Okay, so if I create a generic chef, that means let's say it basically it extends chef of food. Okay, so and we have a meat chef, which is basically specialized in the recipe of meat, you can say, and we have a white meat chef, who is basically specialized in the recipe of white meat. Okay, now let's see how it is implemented here. So, okay, so you can see that like we can create an instance of white meat chef. Okay, and so basically this white meat chef, it can only cook white meat, right? And we can create an instance of meat chef. So basically like you already know that white meat is a subtype of meat, right? White meat is a subtype of meat. So in case of contravariance, the chef of meat is gonna be subtype of chef of white meat. So this is how it's gonna be. So in case of generic chef, like you know that white meat is a subtype of meat and meat is a subtype of food, but in case of contravariance, the relationship is going to be reversed. That means chef of food is a subtype of chef of meat and the subtype of chef of white meat. Okay, so we will see when I'll switch back to the slides, I can show you what is the significance of this. So let's take an example of invariance. So I created a restaurant here, trade restaurant, and it has all of these entities. It has all of these methods, and we can simply create a generic restaurant, which basically extends restaurant of food, restaurants of meat, restaurant of white meat. So it does not matter that what is the relationship between white meat, meat, and food. It is not going to affect the relationship between, because there is no relationship between restaurant of food, restaurant of meat, and restaurant of white meat, right? They do not have any relationship because it's of type invariant, right? So let's switch back to the slides and let's get a more clarity on this. 1 second. Okay, so basically this was the example I took, that white meat is a subclass of meat, and meat and vegetable, they are subclasses of food, right? So when we talked about covariance, what we did in that case, this is what we did. Like you know that white meat is subtype of meat and meat is subtype of food, right? But in case of covariance, if you create a recipe of white meat, okay, it is going to be a subtype of recipe of meat and it is going to be subtype of recipe of food, right? So it follows the relationship of, it is an example of covariance, right? Now, if we move forward. So in case of contravariance, white meat is subtype of meat and meat is subtype of food. But in case the relationship is reversed here, that means chef of white meat, that means chef of food is basically subtype of chef of meat, and chef of meat is basically subtype of chef of white meat, right? So the relationship is reversed here. Now, what is the significance of this? I mean, if you want someone to cook white meat for you, okay, so in that case you will be able to declare this chef of food. That means a chef who can cook any food, right? So this is the significance of contravariance here. Okay, now there is just one last topic, that is how, I hope you guys have heard about this Liskov substitution principle. I hope you guys have heard about solid principles. So basically in the solid principles, that L, it stands for Liskov substitution principle. So what it says that functions that use pointers to base classes must be able to use objects of derived classes without knowing it. Right? So that means if S is a subtype of T, then the objects of type T may be replaced with the object of type S without changing the behavior of T. So we already saw how it works, right? Okay, moving on. So basically, let's wrap up the session. So in this session, we introduce the concept of like type constructors and generic types. And starting from the notion of subtyping defined for simple types, we showed how the subtype concept, it translates to type constructor through the definition of variance, right? We looked at 3 types of variance: covariance, contravariance, invariance, and we concluded that if we use a generic type variable assignment, we need to use covariance, and if we use a generic type as argument, we need to use contravariance. Okay, so okay. So basically, we can simply summarize the things here. Like in case of covariance, the notation is this, plus t, and if S is subtype of t, then list of S is also subtype of list of t. And in case of contravariance, the notation is minus t, and if S is of subtype of t, then list of t is subtype of list of S. And if we have invariance, which does not have any notation here, so if S is subtype of t, it does not matter. List of S and list of t are going to be unrelated. I hope it's clear. That's it from my side. I can stop sharing. Thank you, guys. Any questions? Anyone? No.
So do we have any questions? Anyone?
So, Mansi, have you seen any example of contravariance in your code?
No, Bhavya, I haven't seen any example. Like I've never implemented contravariance, but I think that we never took it as a practical approach, but it is. So we can, it does have its significance, as I already explained. So we can think of it. Yeah.
Okay.
All right. So thanks, Marcy. Thanks for this wonderful session, and thanks everyone for coming over. We look forward to another discovering another session in a matter of 5 more minutes. So let's take a quick tea break and come back fast at 16:15 hours. So thanks once again, and do not forget to share the feedback for this session. Thank you so much. Have a good and great day.
Thank you.
And thanks, Mansi, once again.
Yeah.
Thank you.
Thank you.